Hi everyone! Today we're going to take a virtual tour around Hamilton, Ontario to look at the Niagara Escarpment and some of the rocks that we'll see there. So here's a quick view from Google Maps of the Hamilton area and the escarpment. So you can see the escarpment. It's this ridge right here. It's a very interesting geological feature and we're lucky enough to have it in our backyard basically. Here's the original walk that we were all going to go on. We were going to walk around Shadok Falls. We were going to head down some stairs, take a peek at Cliffview Falls, as well as a lower falls. We were also going to walk along Bruce Trail a little while to see some of the rocks that we could find. So we're going to do that virtually today, but before we do, I want to set the stage for you. We need to rewind time a little bit if we want to understand the Niagara Escarpment. And we need to rewind time about 420, 450 million years ago. Now, because of plate tectonics, all of the continents on the Earth were in a very, very different location. On this map right here, you can see North America existed at the equator. So we were tropical 450 million years ago. And what's really interesting is, in our location, we were on the shores of a large tropical sea. Beautiful, temperate weather, pretty simple life forms at the time, but whatever. It was warm, it was great. Here's us right at the equator. This diagram shows the outline of the large tropical sea that dominated the Great Lakes area 420-ish million years ago. This is now called the Michigan Basin because it's centered in Michigan. Now, this basin is deepest at the center in Michigan, and it kind of scoops up like a bowl, where we are at the edge of that bowl, right at the Niagara Escarpment. Over time, the bottom of this tropical sea filled with layer after layer after layer of sediment. And over time, it turned into this bowl shape. So the edges of all of those layers of sediment ended up curving upwards at the outside. And over time, with lots of erosion, the edges got cut off. And we're at one of those edges. So we can actually see all of those layers of rock, all of those sediments that have lithified into rocks. And all it takes is a quick trip down the escarpment to go through almost 50 to 100 million years in geologic history. Now, you may recall we talked a little bit about the process of transgression and regression. If we have a body of water, at the beach, we're going to get deposits of sandstone. A little bit further out into the body of water, we're going to get smaller sediments that are deposited. Those will probably turn into shale or something like siltstone. Further out where we have coral reefs, and yes, even 420 million years ago, there was sea life that had shells that was made of calcite, and there were coral reefs. They will eventually turn into limestone. As the shore of that ancient sea or body of water increases or decreases over time, you're actually going to have the layers of limestone, shale, and sandstone moving on top of each other, depending on where the shoreline is at that point in time. So as we go down the escarpment virtually, you're going to see regions of limestone, dolostone, siltstone, sandstone, shale, and they're going to switch as we go up and down, and that just is telling you whereabouts in that ancient tropical sea Hamilton was located at that point in time. Now, here are the most important layers that we're going to be able to spot on any walk around the Niagara Escarpment. The top portion of the escarpment is made of a really sturdy dolomite, limestone and dolomite, called Lockport dolomite. It's about 415 to 420 million years old. Immediately below that blocky brick-like dolomite, we have a darker layer of shale. Shale, you may remember, is lithified mud. It's very poorly cemented, it's very easily eroded. So even brushing your hand on it, sometimes it'll come off in your hand. Below that, we have more blocky layers of limestone and dolomite. Below that, we have a very interesting small layer of sandstone, actually easily weathered sandstone, that's almost a grayish blue in color. It's very distinctive. Below that, we have the Grimsby sandstone and shale formation, which is thicker and is red. Below that, we have a darker Power Glen shale, which is very easily eroded again. Below that, we have something called whirlpool sandstone, which is a very beautiful, almost white sandstone. And below that, we have more red shale, which is again very easily weathered. So as you can see, we're going down about 100 meters in this cross-section of rock, going from 415 million years old at the top, all the way down to older than 430 million years ago at the bottom. Now that's not the end of the story, because about 20,000 years ago, this whole area was covered by a giant glacier. This is a really cool image from the cartoon XKCD, where he shows how tall the ice sheets would have been 20,000 years ago in places like Toronto, Chicago, Boston, and Montreal. As you can see in Toronto, as we were at the time, we were under about 2 kilometers of ice. So that's going to definitely gouge and carve the landscape up and is responsible for a lot of features that we have in the area as well, which we'll talk about later. Now, on our original walk, we were going to walk through Scenic Drive, we were going to go down some of the staircases, so we'd be up close and personal with the side of the wall, and we were going to peek over the edge into certain regions to take a look at some nice cross sections. One of the falls we were going to look at, not much of a falls, but a nice cross section of rock, is this one here. If you look very deep into this cliff, you can see some red at the very bottom. That red actually represents the Grimsby Sandstone Shale. Right above it, it's hard to see in this image, but right above it, you're able to see a little bit of the Thorold Sandstone. So the red is the most easy to pick out in this picture right now. That's our Grimsby Sandstone and Shale, and you will be able to see some greenish blue pieces just above it, which is our Thorold Sandstone. Now at the base of the stairs, this is a different waterfall, but at the base of the stairs, there's a very beautiful waterfall just opposite the golf course. This waterfall is unfortunately blocked off by a chain link fence, but if you peek through it, you can get a great view. The top of this waterfall has some beautiful limestone dolomite ridge where the water's cascading off. Underneath it, there's a sharp curve in because the region underneath that limestone is more easily eroded, but you will be able to see a very distinct bluish band. That's the Thorold Sandstone. Below it, we've got our Grimsby Sandstone, which is distinctively red. And fallen at the bottom, you can see some of the pieces of the upper layers that have eroded over time. The other interesting thing to see as you walk along Bruce Trail are pieces of limestone that have been cut out from the top layers of the escarpment and brought to the bottom. So you'll see a lot of these around Hamilton. A lot of them are used as decorative pieces. If you look close, you'll be able to see some fossilized imprints. Here's an example of limestone that's just sitting around the bottom of the escarpment near the stairs. You can see some very clear shell imprints all over this one. So shells, very simple marine creatures, were plentiful at the time in this beautiful tropical sea that eventually turned into the limestone. Another really interesting feature that we can't visit, but I recommend visiting once it opens up again, is called the Devil's Punch Bowl. It's just off the Red Hill Valley Parkway. The Devil's Punch Bowl is a large carved out region of the ground where you can see beautiful vertical layers of the escarpment. Almost all of them, if you go for a walk, you'll be able to see all the way from Lockport Dolomite down to Queenston Shale. Now, here's the best view of the Devil's Punch Bowl when you're right down at the very bottom. Here are all the layers you can see. The very top layer, you can see Lockport Dolomite. This is very distinctive because of its blocky shape. After that, we have a distinctive dark region, which is the Rochester Shale. Below that, we have more layers of limestone and dolomite. You can see from this image the thin blue-gray Thorold Sandstone, almost greenish in places, followed by the Grimsby Shale or sandstone. Below that, we've got some Power Glen Shale. Now, you might be thinking, well, what about the other two layers? You have to walk a little bit to find those when you go visit the Devil's Punch Bowl. Walk a little bit, you'll actually get an up-close view of some Power Glen Shale. It's so flaky that if you run your hand along it, it'll break off. If you pick up some of the little pieces and crush it in your hand, it'll turn to dust. That's how poorly cemented this sort of rock is. Now walk a little bit further and you're even lower down on the escarpment. You will be able to see another waterfall, a much smaller waterfall, but this one allows you to view the Whirlpool Sandstone and underneath it, the Queenston Shale. You'll be able to see the Queenston Shale because it's bright red, and right above it, there's some nice, almost white, fairly robust Whirlpool Sandstone. If you're looking for another good walk, you can always try the rail trail, which goes along the 403. So you'll hear the highway in the background as you're walking along this trail. Now, when you start at the top of the escarpment, you'll be walking by very big brick-like structures. That's our Lockport Dolomite. Here's a beautiful waterfall. I believe it's called Princess Falls. And you can really see the nice brick-like structure of that Lockport Dolomite here. Here are some interesting features of our Niagara Escarpment. One of the things Hamilton is known for are its waterfalls. There are many waterfalls. When the trails open, I suggest going out and investigating them. They're beautiful. One of the reasons that Hamilton is made up of so many waterfalls is because the escarpment has layers of rock that some of them are very robust to erosion, some of them are very, very easily eroded. So it's easy to carve gouges in them. One of the things responsible for carving gouges in rocks are glaciers. And we used to be covered in glaciers tens of thousands of years ago. Those glaciers carved out huge chunks of rock that resulted in beautiful waterfalls that we have today. The other interesting thing that glaciers did, not only did they carve out rock and scrape up sediment from the top of the escarpment, they dumped them at the bottom of the escarpment. So at the bottom of the escarpment, we have extremely fertile ground, lots of nutrients that get deposited at the bottom. And so what do we have today at the bottom of the escarpment? Hint, lots of wineries. So we have a lot of really unique geological features in our backyard. So I recommend you go out and investigate in the near future.